Everyone, welcome to Tuesday. Hope you all had a nice sleep. A few people are still doing this sort of thing, so we'll start off now. Good morning. My name is Jay Hannon. I work with IBM, and I'm the session chair coordinator for this morning's speakers. So we have some very, very good speakers this morning. Just had to ask to turn your mobile phone call with you. Our first speaker this morning is Philip Laxton from Dell. Philip's a senior HPC engineer with a very long industry experience of architecting and deploying very large HPC systems for research organizations like yourself across the Asia-Pacific area. But Phil is going to talk this morning on Dell OpenStack with Crowbar. So, Phil, over to you.
Morning, everybody. As I said, Phil Laxton from Dell. Just a question before we start. Can I show of hands anybody who's heard of OpenStack? Anybody actually using OpenStack? Oh, very good. Anybody heard of Crowbar? Anybody using Crowbar? Like, you can come and do the presentation. I think you've got more experience than me. Anyway. Anyway, we've just got 15-20 minutes, so we'll get stuck into it. So one of the things that I came across when investigating this stuff is this term DevOps. I thought I might just sort of explain it, because I'd scratching my head trying to figure out what it was, and we love our buzzwords and our acronyms and things. So I guess it comes from, traditionally, you had the development team and then the operations team. So back in the olden days, people would come up with their punch cards and hand it to the operators, and then come back a week later and find the results of your job on printouts and things like that. So with the advent of VMs and things like cloud and OpenStack, etc., the differentiation there is starting to blur a bit. So they've come up with this term DevOps, because part of your operational processes is deploying VMs and things. So really, you're sort of on the infrastructure side, but also on the development side. So DevOps basically refers to this term of infrastructure as code. So you bring up a VM, run your code, and then it disappears. So obviously, resources that are easier to. Wrong button. So resources that are easier to recreate than change, and that's the way we do it with cloud and this sort of model. Obviously started with Amazon, who were obviously very, if not the first, very early into this cloud that we've been talking about for many years. So that's sort of a rough overview of what DevOps is, as far as I'm concerned. So OpenStack, what is OpenStack? Operating platform, so basically an open source toolkit for orchestrating clouds. It's basically an open source community with various community maintained projects. Started back in October 2010 with the Austin release, which is basically, as far as I know, just basically compute. So very early days. The latest release, the fulsome release, was released in September, and the different projects. We keep pressing the wrong button. Sorry. Compute, object storage, which is where you'd be saving all your VM images, etc. The image service, which is where you request the images. Authentication across the nodes within the OpenStack cluster. A dashboard, which is obviously where your users come in and request services, etc. Network, there's various VLANs, etc., that run around within the OpenStack configuration for storage and compute and that sort of thing. And block storage. So obviously, once your VM disappears, anything that you've written within that VM disappears, but block storage can then be connected to that VM so that you've got your data saved afterwards. So the requirement from OpenStack was, clouds to be, simple to implement and massively scalable, whether that's a private cloud or a public cloud. And it supports the open standards such as the Amazon APIs. It supports multiple hypervisors on your compute nodes, the usual suspects there. And more information from OpenStack.org to have a closer look at that. There's also lots of information on YouTube, which I thought YouTube was just for showing cats playing the piano or people falling over, but there is some useful technical stuff on YouTube these days. So lots of good information from Dell and other people about OpenStack, etc. So just a bit of an overview of the basic building blocks of OpenStack. You've got your dashboard up here where your users come in, request a VM that gets brought in from the object storage through the requested by the image server, brought in from the object storage, instantiated on one of your compute nodes. You've got network and block storage, which can be, as I say, used for local storage, and also what the keystone authentication runs around through the whole infrastructure there. So what's Dell been doing with OpenStack? Been involved since the early days. Dell launched a OpenStack solution in July 2011, and that includes a number of things, including a hardware reference architecture. So we've got pre-configured, pre-tested configurations for an OpenStack deployment. There's also the Crowbar tool, which we'll talk about in a little while. Lots of video press releases, etc. Partnership with the key members of the OpenStack community, and Dell experts visible in the OpenStack community. So, for example, one of the Dell employees, Rob Hirschfeld, is on the OpenStack board. Lots of details to be downloaded from the Dell website or the OpenStack on the Dell website there, with all your reference architecture, how to build it, how to install it, that sort of thing. So this is sort of an overview of what we've got within the solution from Dell. So we have the reference architecture, as I said. So that includes our PowerEdge and PowerEdge C servers. For those of you who don't know, the PowerEdge is your standard rack mount servers. The PowerEdge C is your scale out style servers. If you come up to our stand up on the second level there, we can show you one of our C6145s, which is a typical C-class PowerEdge server. So that's our range of PowerEdge servers designed for scale out, so your big, thousands of nodes, etc. And they make ideal nodes for your compute within an OpenStack architecture. So obviously storage and compute, Force 10 and Power Connect network switches. The standard reference architecture has a minimum of 6 nodes. But obviously you can scale up onto that. The software part of the stack is the OpenStack installer, which is Crowbar, that we'll talk about soon. Obviously the OpenStack cloud software, and there's other software elements installed by Crowbar, your management tools such as Ganglia and Nagios, etc. The operating systems that our solution currently is supported on is Ubuntu and Red Hat, with Windows guests and other Linux guests. I guess at this point I should point out that OpenStack can be run on anything, and indeed Crowbar can be run on anything. So Dell offers, I guess sort of offers 2 versions. You can simply download the open source version, or there's a particular Dell version with a couple of extra little bits in there that gives you a bit more support around our PowerEdge servers. But we'll have a look at that in a sec. then the hypervisors that are supported on our solution at the moment is just KVM and Zen. The services that can be done by Dell for this is on-site hardware install, software install, training sessions, obviously Dell just standard pro support on your servers, and OpenStack support. So if you're after the Dell supported version, which will give you some extra functionality in the Crowbar side of things, then there's an OpenStack support agreement to get those extra bar clamps that'll do some things like updating your BIOS on your PowerEdge servers, configuring storage, etc. automatically. And obviously that's just restricted to the hardware that is supported within the reference architecture for Dell. So that's a bit of a quick overview of OpenStack. What's Crowbar? I guess the problem is, yeah, OpenStack's great, cloud is great, but how do I do all these things? How do I unbox these things, get from there to a cloud? So how do I customize the hardware if it needs to be done? How do I provision the servers, configuring networks, storage? How do I assign the different roles? How do I decide which nodes are going to be compute nodes, which nodes are going to be storage nodes, etc.? How do I then monitor that cluster? How do I monitor the performance? All that sort of things. And so I equate it to the equivalent of a cluster manager tool for say a HPC cluster. You could run a large HPC cluster with no management tools, but it'd be very difficult. So this Crowbar basically provides you the same functionality as your typical things like ROCs or Bright Cluster Manager, that sort of thing. So I guess one of the problems is that the cloud's changing all the time, especially the open source version. There's new releases coming out all the time. So how do you manage all that change? I mean, as far as running the cloud, you've got the constant changing, the resources constantly changing, and you've got how do you track all these components? As a user, you've got the same sorts of things. Things are constantly changing. You want to be running new versions of the latest software, etc. So how do we do that? Well, constantly continuous deployment. So things are changing, certainly in the early days, fairly quickly. You want to automate that deployment as well, and you want to be able to manage that and monitor that system at a central point. So Crowbar is basically a zero-touch cloud installer. And basically say you can go for servers from servers in cardboard boxes to a fully functioning cloud in under 4 hours. So the three basic functions of Crowbar is provisioning, management, and monitoring. So it's fast and flexible. As I say, the Dell supported version of Crowbar provides an extra couple of bar clamps, which you plug your server in, it'll check the BIOS version. If it's not the latest version, it'll update it to the latest version. Depending on what function you assign to that particular node, it'll then change some BIOS settings to whether it's a compute node or storage node. It will also look at the storage available on that node and configure them into whatever RAID sets, whether they're JBODs or RAID sets, etc. It'll auto discover those servers, so they basically pixie boot off a head node. So very similar, as I say, to a HPC cluster. And the functionality on the as far as OpenStack and also the basic Crowbar services are deployed using these things called bar clamps. So it's an operational model. It's built on Opscode Chef server. So Chef server has this idea of recipes. So basically, Crowbar is a wrapper around Opscode Chef server, and then we provide, or the community provides bar clamps built on Chef server recipes to deploy to your various nodes. And obviously, since it's open source, you can create your own bar clamps. Now, Crowbar is not restricted to installing OpenStack. You can use it for Hadoop, which is the two options that the Dell offers, but it's basically a deployment tool. You can certainly go out there and write your own bar clamps to do whatever you like, really. So this was developed by Dell, but then open sourced back in 2011. So as I say, it's not specific to OpenStack. It can be used with anything, and it's not restricted to Dell hardware either. So any hardware that can Pixie boot pretty much do it. So we can look at the basically from bare metal through to through an integrated cluster. We're a bit short on time, so I might just move forward to another slide. So there's the open management there. We've got each one of these is a bar clamp. So you've got a bar clamp doing your BIOS, IPMI management, your low-level physical resources. The admin server in Crowbar provides DHCP services, DNS, NTP, etc., logging, and then you've got your actual OpenStack bar clamps, depending on what you're putting onto each server, you know, compute or storage, etc. You've got some management bar clamps such as Ganglia and Nagios. All of this is optional. You don't have to install these. You can pick and choose whichever you want. A bit of a marketing slide around the Crowbar software framework, but pretty much what I've said. It's a deployment tool, management tool, monitoring tool, lots of information on the web, lots of information on YouTube about even how to install it and run it, how to demo it in a VM. There's YouTube videos up there on how to do that as well. So a simple way to do it, I mean, if you wanted to simply try it, get your servers, unpack them, network cable them up, download the Crowbar ISO from GitHub, so that's the open source version, install that on your admin node. That's just basically it's already got the pre-seed file already in there for Ubuntu. It'll just install it automatically. Pixie boot your nodes. They then Pixie boot from your admin node. They will come up on the dashboard. Then you can start assigning your bar clamps based on what you want that particular node to be, and then Crowbar does the rest. So really, yeah, you can have maybe not an operational, but you know, if you wanted to try Crowbar with OpenStack, it's very quick to do. This is basically look at the dashboard. So your nodes come up based on their MAC address. You can then rename that to make them a bit more useful. Click on each of those nodes. It'll show you what bar clamps are assigned. Gives you details of the nodes, MAC addresses, and hardware configuration, etc. As I said, Crowbar will automatically install Nagios and Ganglia for you. If you don't like those, you want to use something else, you can create your own bar clamp, or there may already be community support for those. So some people like Nagios, some people don't. So that's all optional. You can install that if you like. That'll do your monitoring of your nodes, where they're up and down, what processes are running, and then Ganglia does the performance management. So just a bit of a marketing slide of the overall solution. So OpenStack on PowerEdge and PowerEdge C servers, Dell networking. We have a reference architecture. We have deployment guides. We have services available to deploy and train and do the hardware and software integration. We're adding hardware to the reference architecture all the time. We're in the process of adding the C6145 for Monash University into the reference architecture as we speak. Any questions? That was all a bit rushed. 20 minutes goes very quickly, so we can make that presentation, or we'll be here for the next couple of days up on the stand if you want to come up and ask questions there.
That's great, Phil. Thank you very much.
Any questions? I've been asked if you want to ask a question, can you please use the microphone, but if you want to yell it out, that's fine too. No?
Maybe it's a bit early in the morning.
Yeah.
If you have any questions that come up during the day, Phil, I know it's upstairs, so that.
Yeah.
So anyway, thank you very much, Phil. And
thank you.